All right. Oh, you're already up. Next up, we have Zaki, co-founder of many projects, also one of the founding fathers of Cosmos. I'll let him take it away. He's going to talk about the modular past and future of Cosmos. Cool.
Thank you. Doesn't seem like it's working. Is it working now? Cool. Awesome. Sweet. Here we go. All right. So, what does Cosmos have to do with Celestia? This, I think, is the hardest question to answer because no one knows what Cosmos is. And Cosmos is sort of this emergent bottom-up effort, or like emergent bottom-up system that like emerged out of like a bunch of work on building blockchains in this modular way that started in 2014. And so, I kind of am frequently the like face of explaining the system architecture to the world, but like credit to Jay for like basically foreseeing like a lot of the problems that like Mustafa and Alex just talked about, which was we want to run a lot of experiments. We want infrastructure to enable running a lot of these experiments. Back in the early days, we were extremely capital constrained. How do you like you could kind of understand the scope of the problem of how do you build like a global financial system, but like it was just like a bunch of people who were like it was like small groups of people who were coding. We had very little money. We had very little resources, and to build all this stuff, how could you actually achieve the system? Another sort of anecdote, just about like how this is all destiny. It was all destined. It was all foretold. The original idea that Jay and Ethan came to me with, which was their idea for a public blockchain, was called Supertanker. And Supertanker was basically the idea of have like one Tendermint chain where you write the block headers from other Tendermint chains to, and then you would do fraud proofs if those Tendermint chains, if those validator sets for those other Tendermint chains like produce an invalid state transition. So doesn't this sound like awfully familiar? But so my objection back then, this is 2016. My objection to the Supertanker design was we don't have a solution to data availability that scales. Like Tendermint blocks can only be so big. We can't write like the transactions for hundreds or thousands of blocks to the Tendermint blockchain. Like we should do something else. And so I kind of like was very much pushing a bunch of other ideas of how you would get sovereign interoperability that I found in like Mark Miller's work from the 90s. And that's how we sort of got to the architecture that we sort of launched in 2021. We had no idea that it would take that long, but like there were many hijinks and adventures along the way. So Cosmos, though, has been this like, so like Mustafa mentioned ABCI. ABCI is sort of Cosmos's modularity. I'll get to a little bit of the origin story of that later. But largely, I would say the modularity that we built into the system has had a number of big success stories. There are a number of chains that have used Tendermint to augment Geth, going back all the way back to 2016, maybe 2015, where like Kobe shows up in the Tendermint Slack and is like, I have Geth running on top of Tendermint. Let's call it Ethermint. And then like, all of this code was open source. A lot of people ran with it. You get things like Polygon and Binance, which are sort of elaborations on this original idea of augmenting Geth with Tendermint. The sort of team, the Tendermint team, like focused on the Cosmos SDK, and we've had a bunch of big blockchains now that like have billions of dollars of value that use the Cosmos SDK chain, the sort of raw Cosmos SDK, and interoperate with the whole Cosmos SDK ecosystem of wallets and block explorers and all these pieces. And you get this like shared component architecture around the Cosmos SDK with strong network effects. So like Terra, Luna, Osmosis, Atom, that all works. Then we also have this like explosion of smart contract VMs that have emerged in sort of this ecosystem. So like you have Agoric, Evmos, Cosmwasm, and probably there's going to be more. It's very exciting. And then you have people who have built like entire alternate application frameworks like Oasis and Penumbra and Anoma and Nomic. So this to me is like, hey, like this is the shining example of like sort of the social and like adoption benefits and how sort of making these choices to build Tendermint through this ABCI interface as consensus separated from application has like yielded like enormous benefits to our entire industry. And so this is sort of to me like why modularism has been good, why I am really happy with like how we went about building Tendermint and Cosmos, because I think all of these things have been massive wins. So our sort of layers of modularity are ABCI and ABCI++, application blockchain interface. So when you build on top of Tendermint, you get this like list that's probably about a page of APIs that you have to provide in your application. And it's like sort of obvious things. It's like, okay, like begin a block. So like what should the application do when a block is when a block comes in? Deliver all the TXs, so execute all the transactions, end the block, commit the block. These are like the sort of standard APIs. It's pretty simple. There are like, if you like look under the hood of many other blockchain stacks, you see like the same design patterns where like basically the same application consensus interface. But what was unique about the Tendermint approach was that we took this approach of sort of standardizing that API. It hasn't changed that much since like 2015, 2016, though ABCI++ is a new thing that's coming out of the Tendermint team to sort of enable all of the things that we didn't foresee. And like, you know, hats off to Dave Oja for like sort of like really extending the API in a general way. But this has like enabled things like Optimint and Celestia to use like ABCI in this really powerful way. But like all of those people on all of those chains on the previous slide are all ABCI users. The Cosmos SDK has like also this modular interface where you can extend it with various modules. This has allowed like very diverse use cases like Thorchain, Axelar, like all of these things like really have like very different systems interfacing throughout this modular architecture. We also built IBC, the sort of built-in bridging protocol to the Cosmos and Tendermint ecosystem in a modular way where you could actually pull out, where you can actually extend the client interface, so like the transport layer, like how do you authenticate like a message coming from which blockchain? So we actually could have multiple security models. And then we've always had like support for many different signing algorithms and many different sort of cryptographic primitives inside of the Cosmos SDK. Has also been a huge enabler and sort of innovation and integration with different ecosystems. Like you see all of these things coming out of the Evmos ecosystem that support like the Ethereum signing algorithm. And like people have tried with to build in support for like Polkadot's signature system as well. Okay, so these are all sounds really great. But we've been doing this a long time, and it obviously hasn't all been beautiful and perfect. So Tendermint itself is a bit of a monolith. It has like excessive interdependency between things like consensus and peer-to-peer layers. And though a number of teams that have tried to build experiments sort of like within that system have failed because of just like sort of the overwhelming complexity of that task. We have a lot of like large-scale users that are also like sitting on ancient versions of the system. You know, like the version of the Cosmos SDK that Polygon is using for their Tendermint chain is, I think, from 2019. It's kind of terrible. We've also seen like a number of teams, like kind of mostly Binance, like as the biggest one, like take Tendermint, make a bunch of changes to it, and then never open source or upstream their changes. Phantom built, there was like the first, so like the dream, one of the dreams of Cosmos was not only could you have many applications built on top of Tendermint, but you could have many consensus implementations, because we don't believe that Tendermint is like the end state of consensus, could also implement ABCI, and Phantom was the first blockchain to do this, but it never really shipped, and it's sort of sitting on the shelf. And then we basically abandoned the idea, though there's some community members who are trying to keep it alive, of like sort of like making the sort of like local database of Tendermint pluggable. Because modularity frequently imposes like a lot of sort of maintenance cost on the core team. Okay, so how did this all start? So Tendermint's modularity came about because of an IP dispute. There was one set of Tendermint contributors who really wanted to GPL the entire software suite, and another set, and Jay wanted to Apache licensed it. In hindsight, I think Apache licensing Tendermint was like a huge reason why the modular systems, why this has become such an important modularity layer. And it's like one of the things that like worries me about sort of the modular blockchain stack is like we're playing too many games with like the licensing and the IP system, and it's going to hold back innovation as people like do like business source licensing and stuff like that. I think getting Tendermint to be Apache 2 licensed was like a huge innovation enabler, especially in those early days of blockchain. So what we did was, like Jay came up with ABCI as a way of separating the GPL components from what he wanted to Apache license. And this is how we got the modular system. That sort of formative thing sort of turned into like the philosophy of Cosmos, which is like sort of this like extremely modular system architecture that I think has really proved its worth. So this is the start of modularity in Cosmos. What's the future hold? ABCI++ is this very composable thing, or this very powerful addition to like the modularity system of Tendermint. You can do a lot of things. You can do MEV mitigations. I think one of the things that you see from, like for instance, Starkware has this proposal about using Tendermint to like decentralize the L2 sequencer. And like you can use ABCI++ to require like a set of sequencers to agree on external data availability before producing like another state update. And so like we sort of somewhat intuitively, somewhat informed by all of these emerging requirements as like sort of the modular stack evolves, and we want to meet the needs of the modular sort of builders of modular blockchains. We are like building these functionalities sort of into core Tendermint to like sort of enable people to do this without forking Tendermint. One of the other questions that we've been thinking a lot about, and there's been a lot of conversations, is can we extend IBC itself to be sort of fit within the rollup paradigm? IBC is this it's currently like somewhat trustless in the sense of, hey, like we have this thing where the packets are authenticated by the validator set of the sending chain. So like if you already trust those validators, which you needed to because you were using that blockchain, there's no additional trust assumptions. But we could build, and we've sort of always wondered about like approaches to building like actual state machine verification. So you actually could move away from trusting the majority of like a minority of those validators to just being able to say, hey, like the bridge itself authenticates or has fraud proofs. And all of this stuff actually composes very nicely into like sort of the overall design of IBC. And I'm very hopeful that like one of the things that emerges out of the Celestia work is sort of like an IBC ecosystem that does sort of trustless settlement or like state machine verifiable settlement, but across like in this sort of like multipolar IBC world rather than in this like sort of like hierarchical like settlement layer up world. We've been, going back to the supertanker story, we've been thinking about fraud proofs for the Cosmos SDK. Also, like if you if you go back to the historical split between Polkadot and Cosmos, it was like we wanted to do like interoperable multi-chain blockchains, and Gavin and Rob were like, yeah, we want to do all that too, but we want fraud proofs, though they didn't end up actually doing fraud proofs. But I think we have like a relatively good architecture for like adding fraud-proof support to the Cosmos SDK, and that'll allow it to sort of start like you to build applications in the Cosmos SDK. So open questions. We still really haven't, like I've been like working in the zero-knowledge proof ecosystem for many, many years, but we still haven't been able to figure out exactly where zero-knowledge proofs like fit in the Cosmos ecosystem. And I still think that's like an open question. It continues to be like a sort of a constant area of discussion. I talked to the MENA team about using Tendermint for data availability. We talked to the Starkware people about using Tendermint for sequencer decentralization. It seems like there's some piece that Tendermint is supposed to plug into the zero knowledge ecosystem, but we still haven't actually figured that out yet. So a little bit of predictions about the future. Modular and monolithic blockchains are going to coexist for a very long time. There are still, there is a kind of purity to being able to reimagine your entire system from the ground up. And there are things that I don't know how to build in the modular paradigm that I still think are useful in the blockchain space. But modular systems will outperform on decentralization. I think one of the coolest things about Cosmos is the sheer number of teams that contribute at every layer of the stack. And it is going, what you will see, what I expect to see with Celestia, is now you will start seeing teams that are building settlement layers and roll-up SDKs and zero-knowledge proof, execution environments that are all built on top of Celestia, but they're also going to contribute to the core data availability layer. They're also going to find bugs. They're going to improve the because as you build these modular architectures, it's very friendly to sort of modular organizational structure because you can have different organizations own different parts of the stack. They kind of can and you also have incentives because you're building at one layer to fix problems or improve performance at other layers of the systems. Finally, I have a project called Sommelier, and Sommelier is to me the best example of a thing that doesn't work in the modular environment. It is a blockchain that is sort of coordinating DeFi strategy execution on other blockchains. And really the only way to do this is if you own consensus up in sort of your core application stack. And so this would be my counter argument to the modular blockchain thesis is going to rule them all. There's still going to be a place for monoliths. I certainly have a lot of experience building them, and that will be that. Yeah, and the other thing is I think stuff sort of the direction that many of Mustafa's co-founders on Chainspace have kind of gone down with Mistin and Sui is another great example of how you are building highly very interesting monolithic systems are still to be built. So thank you very much.
Questions?
Do you want to do questions?
Take some questions, yeah. Any questions? Can't see. All right. Time for my walk. Excuse me. Here you go.
Can you comment on the use of Optimint with the Celestia stack in terms of modularization?
Yes, so Optimint is an alternate ABCI provider. So Tendermint is the normal ABCI provider, and Optimint is an alternate ABCI provider. And the expectation is, the way I think it's going to work is we are going to add new APIs to ABCI on Optimint that add what's necessary for fraud proofs in the Cosmos SDK, and then we'll add them on the Cosmos SDK. And then the dream is that eventually gets upstreamed into sort of the Tendermint provider. And so we continue to have one ABCI, but now we have these fraud-proof mechanisms. The other thing that Optimint is, I think, we need to figure out is exactly how we're gonna, because right now leader election is owned inside of, so one of the questions I think is about this is in Tendermint, leader election is owned inside of Tendermint. It's not owned inside of the application. And we either need to change ABCI to move that over, or Optimint will just have a standard leader election system for rollups and sequencers on top of Celestia. Did that make any sense? And was that
Yeah,
helpful?
thanks.
Yeah.
Thanks. Anything else, guys? Any other questions? Aha. All right. Is that it? Oh, there you go.
Thanks for the presentation. My question is, do you think that in the future monolithic chains will be more of a niche product that solves, let's say, only one use case? And if it is, the follow-up question is how in the future you think monolithic chains can scale?
So there is sort of, the reality of the situation is like there's plenty of room to scale monolithic chains. You do have to like exponentially increase the amount of resources that are involved in like sort of the core engineering, but like there's plenty to do in the in sort of monolithic scaling to get like an order of magnitude, 2 orders of magnitude throughput. The real reason why I think modular wins or like modular is sort of so like fundamentally important and like is basically like the future of finance layer is because what we need is the infrastructure to become public goods. We need to like disperse the knowledge of how to maintain and build and improve and bug fix this to a very large community. You need lots of contributors. And really, the only 2 systems that I think that have ever done this are like the Tendermint ecosystem and the Ethereum ecosystem. Everything else, like the knowledge of like how to maintain the core system, how to improve the core system, how to change the core system is really like siloed in a very specific group of people, typically a company. And like the modular architecture is the only way to do that. And that's the only way we're going to build a system that is like fundamentally different from like the legacy finance systems that we're trying to replace. And so my general bet would be like you may see monolithic systems really succeeding in like gaming, gaming, NFTs, like all of these other more entertainment applications. But I do think that the Ethereum sort of team and this, is very right in their sort of directionally right that like if you want to build the future of finance, modular is the only way.
Thank you.
Questions? No?
No, right behind you.
Where? Go ahead.
How trivial or non-trivial would it be for a monolithic blockchain in the future to evolve into part of a modular one as sort of a roll-up?
So like Alex was basically suggesting that it is more of a continuum than like an absolute. And there's an extent to which that's true. But like I really think about these things as the social process of building them as being like what overdetermines like the future technical direction rather than like what the actual constraints of the software, because like, and so what I've yet to see is ever a project that started out building like sort of a monolithic architecture ever ending up with the social organization to do a modular, to like build modular. They just don't know how to run a multi-stakeholder process, right? If you like the success of a monolithic blockchain comes from doing the opposite, like not running a multi-stakeholder process, being like, we are going to build a blockchain, we are going to make these technical trade-offs, like if these don't work for you, screw you. That is the way in which you successfully build a monolithic blockchain. If you want to build a modular blockchain, you have to run this like multi-stakeholder, multi-entity process, which is very messy and it's like harder to like figure out what's going on. It requires a lot of engagement. We see it in Cosmos, we see it in Ethereum, like happening in real life, and that is a very difficult social shift. So I think if innovations from the monolithic blockchain world actually make it into the modular blockchain world, it's mostly going to be like forking the code and like rebuilding the social infrastructure rather than like people, like the monolithic people being like, okay, we like have gotten to the end of our monolithic story and we now are going to build a modular system.
Thanks very much.
Thanks. All right. Anything else? No questions. Okay. There we go.
That was really interesting talk. I wanted to ask you, you mentioned that there are some features or functionality in monolithic blockchains that you think would be, or you don't know how you would build in a modular blockchain? So I was interested in like what are the most challenging things to build in a modular system that currently exist in a monolithic?
So what are the things that make some of these things really hard? One is where you want so there's the story basically comes down to situations where you can tightly couple the properties of consensus with the properties of the application. So if you can, you want to change the rules of block production in a very specific way that's about observing external systems, what you need is sort of monolithic total control. You want to change. You want to have encrypted transactions that that are decryptable. You want to be able to control your scheduling in such a way that you can execute, that you react to and execute to events autonomously from other blockchains. All of this kind of tightly bound integration between consensus and the application still represents something that's very hard to build in my mind in the modular ecosystem.
Cool. All right, I think that's it. Cool. Thanks, Zaki. Just like that.